Okay, we are good to go and start finally talking to our database. And in order to do so, first of all, we will need a Rastassian model. We need a way to represent our Rastassian database entries into a Rust struct. To do so, we will make this model rs file. In here, we will make our struct, our Rastassian struct. This is the place where we usually put all of our models. It is more or less standard by now in the Diesel world to put our models in a separate file like this. So we have a struct, and then in this struct we have all the database columns basically as Rust fields. We have ID, integer, we have name and email as strings, and then we have created at also as a string, which is like probably not the ideal data struct to use here, the data type to use here. Probably date time is better, or something more fancy like the chrono crate that a lot of people use for this by now, but we will keep it simple for the purpose of this tutorial with just a string. Okay, now we can go back to our main rs file and declare this module, so we can make use of this Rastassian struct models, and then we also want to make use or declare our schema rs module that was auto-generated by Diesel. So schema. This module will give us access to the Rastassian table that was generated, and here the compiler already starts complaining about the non-existent macro that we use in the schema rs module, so we'll have to specify macro use up here. And now great, no more compiler warnings. Okay, so let's go back to our get Rastassians endpoint now. We will remove this hard-coded value, and instead we want to talk to the database. I will remove the prefix also and start making real use of our database. This db value that is being passed in our function, our endpoint function, is not a connection, it's not an SQLite connection, it is actually the pool that our endpoint receives. So in order to get to the connection from the pool, we need to basically call this run function, and inside this run function we will have a callback. We will specify a callback, and then this callback will have access to the SQLite connection. We are going to call it C, and in here we now have a connection, and we can start querying the database table via the connection. The thing is that this callback will run asynchronously, so the pool will try to come up with a connection. After it retrieves the connection, it will run this callback, but it will run it in a separate thread, or I don't know, somewhere that might not be the same thread that this endpoint is being run in. So we need to basically wait on this to finish, the whole process to finish, and then afterwards return the response in our endpoint. And in order to accomplish that, we will just await the async function or the callback to finish, and then afterwards we will return the response. But now that we have specified the await keyword here, Rust forces us to also use the async keyword for the function signature up here, so it now knows that the function deals with the async and to treat it differently. Okay, so now we are in This callback, we have connection available, we have the SQLite connection up here, so we are free to run queries. How do we do this with Diesel? So the way to do this is by basically using our table now from the schema. So we can call our schema Rastasians table, and then here we can call this limit function to basically limit the records that we will retrieve from this table. This is a query now. This is a query now, and we will limit this query to 100 records. And then afterwards, what we will do, we will try to load these records and translate them into Rastasian models here. And the way to do so is by calling the load function, and then this load function might somehow fail, so we will actually panic, so we will expect it and then use some kind of an error message. Let's call it failed to read Rastasian's entry. A lot of things can go wrong because I don't know, some connection is not available, and or the connection failed itself, so we should be ready to panic here. Of course, we can handle this in more graceful way. Panicking is never good for a Rust application, but this is just as a quick way to make this work. Later we will make it prettier. Okay, now the compiler is complaining about the limit method because it doesn't find it. In order to find it, we will have to include and import some Diesel specific functions from prelude asterisks. Okay, and then we did the query, we did the load call, but we need to somehow tell Diesel to put these entries into Rastasian structs. So whatever this load returns, it needs to be a Rastasian struct. And then we need to also pass the connection here. So the load call will accept the connection from SQLite, the SQLite connection. And then if everything goes well, we will have the result. So let's assign whatever the outcome is to the result variable. And then in the end, what we're gonna do with the result, we want to make it a JSON value and return it to the caller. Of course, this will not really work now because the JSON create the CRD does not know how to translate Rastasian into JSON, and this is why this is complaining, because our struct does not implement the serialize CRD trait. So the way to do this, to make our struct implement that, we will go up here and add an attribute. We're gonna make use of it, the derive attribute by Diesel, and in here we will specify CRD serialize. But the thing is that CRD right now is not compiled with support for Diesel's derive feature, so it is a feature that comes not by default enabled. We will have to specifically enable that. And in order to do so, we will have to come here and manually include CRD. Up until now, CRD was included as a dependency. It was compiled in our program because CRD JSON depends to CRD, but we didn't have the feature of derive enabled. So we will add the version to be one like CRD JSON below, and then features we will add derive here, and then now CRD knows to enable support for Diesel's derive feature, so we can now derive serialize for our structs or our models, and then just like that, CRD knows now to translate our struct into JSON. See, this is no longer complaining. We can successfully convert all the Rastasian records that we will receive, all the Rastasian structs that we will receive from the database to JSON like this. Let's make this prettier and use also schema and then Rastasians, and so that we make our table look fancier. So this is a lot easier to read now. We have the Rastasians table, retrieve 100 entries, load them into Rastasians, and yeah, if something goes wrong, output this message, which we will fix later. Okay, the compiler still complains because we are missing one more thing from our Rastasian struct, and actually this error message makes it really clear. It says that we need to add this queryable trait to our Rastasian. So we will go here, and after serialize we will also add queryable. This is a trait coming from Diesel, and basically it means that we can use this struct as a result of a query. So the query result can be transformed into Rastasian. Okay, now the compiler does not complain anymore for anything. So let's try to compile the program and see if it works. Looks like it does. In that case, we will go ahead and try our endpoint, although it will probably give us an empty result because we do not have any Rastasians in our database yet. But yeah, in any case, let's go ahead and curl it. And remember, now we need the header, the authorization header, for it to work, because otherwise we will receive 4.1. So let me find not the delete. There we go. The get endpoint with authorization header. Let's hide also this sidebar to make it clearer. There we go. We will receive an empty JSON array, which is the expected thing to receive here, since we have no Rastasians. Later we will add some logic in here in the create Rastasians endpoint, and we will also give some life to our get Rastasians one.